All right, today we're going to build a modern AI agent right from the ground up. We're going to cut through all the jargon, RAG, vector databases, LangChain, and actually see how all these pieces click together to solve a real practical problem. So let's just dive right in with the biggest question of all.
I mean, this is really the million-dollar question, isn't it? You've got this amazingly powerful AI, but how do you get it to be an expert on your company's private information? All those internal docs and data, without it just, well, making stuff up.
So to make this real, let's imagine a company. We'll just call them TechCorp. Now they've got a massive 500 gigabytes of internal files. We're talking product specs, support tickets, HR policies, the whole shebang. They want an AI assistant that knows every single bit of it. But they're about to run into a huge wall.
And that wall, it's the AI's memory. See, before we can even think about building anything, we have to get our heads around this one fundamental limit that every single large language model has, no matter how powerful it claims to be.
This limitation is called the context window. And honestly, the best way to think about it is exactly like short-term memory. It's the space the AI has to hold all the info for the current conversation. Everything you say, everything it says, plus any documents you give it, it all has to squeeze inside this window.
Now, you've probably heard about these massive context windows, right? Like Google's Gemini 1.5 Pro. It can handle 1 million tokens. And a token is what? About 3/4 of a word. 1 million sounds like a ton of memory. Problem solved, yeah?
Well, not so fast. That huge 1 million token window, it can only hold about 50 standard business documents at a time. For TechCorp's 500 gigabytes of data, that's just a tiny, tiny drop in the bucket. There is no way they can stuff all that knowledge into the AI short-term memory.
This analogy just hits the nail on the head. Even with a giant memory capacity, there's a practical limit. So the goal isn't to make the AI memorize everything at once. The real trick is to give it the right information at the right time.
So if we can't just rely on raw memory, we need a smarter way to search. And the solution is to stop searching for keywords and start searching for meaning. And this is a total game changer.
Just look at the difference here. Old school keyword search versus what we call semantic search. If a TechCorp employee searches for time off, a keyword search is dumb. It might totally miss the official vacation policy document because the exact words aren't there. But semantic search, it gets it. It understands the intent and finds all the related ideas.
Now, the magic behind this is a technology called embeddings. What happens is an embedding model takes a piece of text, a word, a sentence, whatever, and turns it into a long list of numbers. We call that a vector. But here's the crucial part. Texts with similar meanings get turned into very similar sets of numbers. That's how the machine understands context.
So for TechCorp, the whole process looks something like this. First, you chunk all 500 gigs of documents into smaller, more manageable pieces. Second, you embed every single one of those chunks, turning its meaning into one of those numerical vectors. And third, you store all of those vectors in a special database built just for this, a vector database.
Okay, so TechCorp can now find any piece of relevant information almost instantly. That's huge. But how do we actually connect this new search power, the language model itself, and some kind of conversation memory into a single working AI brain?
Well, you could try to build it all yourself, writing custom code for every little piece. But just look at the difference when you use a framework like LangChain. Connecting to an AI, that's one line of code. Storing the conversation history, it's handled for you. And get this, if TechCorp ever decides to switch from OpenAI's model to, say, Google's Gemini, it is literally a one-word change instead of rewriting the entire system.
So here's the key takeaway. LangChain is like the universal plumbing for your AI agent. It's this abstraction layer that handles all the messy connections between the language model, the memory, and our new vector database. It lets you focus on the actual logic of what your agent should do, not all the boring, repetitive setup. Okay, we have all the parts connected, but we have one more really critical step. We have to make absolutely sure our AI doesn't just make up answers. You've probably heard this called hallucination. We need to ground its responses in the actual, factual documents that we stored. And we do this with a brilliant technique called RAG, which stands for Retrieval Augmented Generation. It's actually a pretty simple 3-step dance. When a user asks a question, the agent first retrieves the most relevant text chunks from TechCorp's vector database.
Then, it augments the prompt by stuffing that retrieved text right in there with the user's question. And finally, it tells the LLM to generate an answer based only on that fresh, factual context it was just handed.
And we can get even more precise control over the output using prompt engineering. We can give it 0 examples for a simple task, we can give it 1 example to show it the format we want, or we could give it a few examples to teach it a specific tone or style. For really tough problems, we can even tell it to use a chain of thought, which forces it to reason through the problem step by step to get a much better answer.
So far, we've built a really powerful question and answer machine. But what about more complex jobs? Things that need decision-making and have multiple steps. Let's take this whole thing to the next level. You see, a simple straight-line process of retrieve, then generate just isn't going to cut it for tasks that have forks in the road, or loops, or complex conditions. For that kind of thing, we need to stop thinking in lines and start thinking in graphs.
And this is where something called LangGraph comes in. It's an extension of LangChain built exactly for these advanced workflows. Honestly, the easiest way to picture it is like creating a flowchart for your AI. Each box, or node, in the graph is a specific task, and the lines, or edges, are the connections that decide where to go next. It allows for all sorts of complex paths and even loops.
Now, what if the agent needs to do something more than just read documents? What if it needs to check a live customer database or look at an inventory system? That's where MCP, the Model Context Protocol, steps in. And this idea is so cool. It's basically a universal USB port for AI agents. It lets them autonomously connect to and use pretty much any external tool or API without needing a bunch of custom code.
And when you put it all together, the results for TechCorp are just transformative. A document search that used to take an employee 30 minutes of digging around is now done in under 30 seconds. And the accuracy? It's gone through the roof. We've gone from the hit-or-miss results of keyword search to the super relevant, accurate answers from the RAG system.
This quote really just says it all, doesn't it? We've seen TechCorp go from having this huge pile of static, hard-to-search documents to a living, intelligent system. This isn't just a small step up. It's a fundamental turning point in how any business can access and actually use its own collective knowledge. So, that really brings us to the final thought. We've seen the whole stack, from the basic memory problem all the way to these advanced workflows. So the real question now is, what complex, maybe even impossible problem in your world could be solved by an AI agent that truly understands your data?